Alrighty, guys, we got the last one for transformations. So even though there's a whole bunch more lines here, the last thing that we're going to talk about is a composition of transformations. Now, normally we would do like 2 more sections. I don't know why I have the other line, because we can talk about similarity transformations and congruence transformations, but we've kind of already talked about that. Like basically, if I do a transformation that only involves translations, reflections, or rotations, then I've done a congruence transformation, because all of these maintain the same size and shape. Those things are called isometries, which isometry is just a fancy word for a congruence transformation. However, if I do any sort of transformation, including a dilation, then I've created a similarity transformation because my new shape is similar. It's scaled up by a certain amount or scaled down by a certain amount. And so those ones are like super fun, but they're also a little bit redundant. So we're just going to talk about compositions of transformations on 106 and 107, and that'll be it. And so we're really not going to fill out page 95. I feel bad about it, but whatever. And the word composition just means we're going to do more than one. So like when I have my original pre-image shape, I'm going to do more than one transformation to it, typically just 2, but you could do more than that if you really wanted to. So turning to 106 and 107, I actually want to start on 107 and we're going to write down a couple of things. So we have our composition of transformations, which again just means multiple transformations, like we're going to do more than one. And so the big thing that we have to talk about with compositions is what the notation looks like. What is correct mathematical speak when we're talking about multiple transformations? So our notation here, if I'm going to correctly tell someone how to do a composition of transformations, if I were to do something like T, 2, 1, use this little circle thing, and then R, y-axis. First of all, the way that I say this is translation, or a translation, composed with, so that composed with is that little symbol right there, a reflection over the y-axis. The weird thing is that you're going to hate is that you always do the second one first. So you don't get to start here and go there. You actually have to work your way backwards. So big note. Always start with the last transformation and work backwards. And I know what you're probably thinking. You're like, Misra, did mathematicians just do this to be confusing and to be weird? And maybe a little bit, but not really. The composing function is actually a function you will talk about in Algebra 2. And the way that it interacts with another function is it does the second one first. So like it does this one and then it does that one. I could explain it better now, but I'm going to leave that for the Algebra 2 teachers to do, maybe hopefully me next year. So anyways, there is a good reason for it, and so you got to do it. You have to start at the end and work your way backwards, because it's kind of like one going into the other. So the other thing that I want to make a note on here, actually let me really big note this, like make sure we don't forget. We have to start at the end and work backwards. But I also wanted to tell you some fun facts. Normally, if we had more time, I would have us do a little investigation about this because it's super interesting to see it happen yourself. But some fun facts about doing multiple transformations. If I do 2 reflections over parallel lines, then what happens is like your final image, so like if you start with one, reflect, reflect, that final image doesn't look like a reflection anymore. You really have a translation instead. So if I do 2 reflections over parallel lines, then I end up with a translation that is 2 times the space between your lines of reflection. So kind of what I mean by that is like if we have a line of reflection here and a line of reflection here, if I start over here, like this, and I reflect, and then I reflect. If I look at this original one to the last one, it just got slid over. And if the distance between these 2 lines is 5, then it got slid over by 10. So that's super cute and fun. I love that. And then the other really interesting thing that happens, again, with reflections, if I do 2 reflections over perpendicular lines, then I end up with a rotation, which is so neat, that is 2 times the angle. I guess it doesn't, I misspoke a little bit. They don't necessarily have to be perpendicular lines, just crossing lines. So if I do 2 reflections over crossing lines or intersecting lines, then I end up with a rotation that is 2 times the angle in between the crossing lines. So like if it was 90, then it would be 180, but it didn't have to be. Like it could be that the lines are crossing at a 30-degree angle, and when I rotate it, it'll be a 60-degree angle, which would feel really awkward to do because we haven't done non-90-degree multiples, but super cute and fun. So if I have a line here and then a line here, and I start with an image, I don't know, right here, and I reflect, and I reflect. This total thing here is like a rotation of double the angle in between. So again, if this was something like 60 degrees, then it's a rotation of 120 degrees. So that's super cute and fun. The only other fun fact that I want to point out is that when I do a composition of a translation and a reflection, we sometimes give that a special name. So if I do a translation plus a reflection, and it kind of doesn't matter the order, we sometimes call that a glide reflection. So we call that a glide reflection. I don't know why they change it to glide, but just in case you see it and you're like, what the heck? A glide reflection is just a translated and then reflected thing. Alrighty, so let's just keep going with this one. And guys, we're going to take it step by step here. So if I take a look at this first side on the left here, we're going to start with an original image, then we're going to translate it, then we're going to reflect it. So it's not written out in notation, we're just going to do it. So let's say we start with the triangle ABC, where A is at -1, 2, B is at -1, -1, and C is at 1, 2, 3, 4, -1 right here. Okay, so what I could do is I could do it all on one, or I can do it step by step by using my rules. So if I first write out our points, so -1, 2, -1, -1, and then C is at 4, -1. If I do my translation first, A prime will now be at -3, 5. B prime will be at -3, 2. And C prime will be at 2, 2. And so then I could go graph all of those. So -3, 5. Oop, 1, 2, 3, 4, 5. -3, 2. And then 2, 2. Now I'm going to take this guy. So I'm going to take all my prime points. So A prime was at -3, 5. B prime was at -3, 2. And C prime was at 2, 2. And now I'm going to take all of those and do the reflection rule for the x-axis, which if I'm reflecting over x, I change y. So A double prime now, because I've done two things to it, is going to change y, so -3, -5. B prime, -3, -2, and then C double prime at 2, -2. And then we could go plot that one. So -3, -5 puts A down here, or A double prime rather. And then B double prime will be at -3, -2. And then C double prime to -2. Now, to be totally honest with you, I don't like doing them on all separate graphs like this. Like I can kind of see, okay, yeah, that got flipped down. Okay, yeah, that got slid up. I kind of like to do it all on one, which can be a little bit messy. And so that's why I showed this way here. So if you want to be less messy. But now on the front here, I want to show you a different way that you could do it. And we're not going to use all these boxes. So say I take that same shape, A here at -1, 2, and then B at -1, 1, and then C at 4, -1. What I like to do is just do it all on one. So the translation is pretty easy to do. I'm going to take A and go forward 1, down 3. So A prime will be here. Forward 1, down 3 for B prime. And then forward 1, down 3 for C prime. However, then when I get to the rotation, I do write it down. So the last thing we want to do is rotation of 270. So I am going to have to write these primey points down. So it's not always like, easy just on a graph, but A is at 0, -1. B prime is at 0, -4. And C prime is at 5, -4. And so if I do a rotation of 270, we switch and change the second one. So A double prime, I'm going to switch. Can't change the second one. B double prime, I'm going to switch. Can't change the second one. And C double prime, I'm going to switch and change the second one. So I like to do it all on one because I can just see it more clearly. Like here's my translation, and now this is going to get rotated counterclockwise 3 quadrants. So 1, 2, 3, and it's going to end up in here. Now, to me, I see the pizza slice pointing right. So when I rotate it once, it points up, then it points left, and so it should be pointing down when I get it all the way over here. So if we go plot these, hopefully it looks good. So it's always a surprise. A double prime is at -1, 0. B double prime is at -4, 0. And there's still 3 away, so that feels good. It should be congruent still because I haven't done a dilation. And then C double prime is at -4 comma negative. So it's pointing down, yay. And it's the 3 quadrants over, and so that is my final shape. So again, either way is fine. Like you can use separate graphs if you feel like it's going to be too messy to do it on just one. But for me personally, I like to do it on just one. Alrighty, let's try a few more. Now, the way that I've written these in here, it's not in like correct notation. So because this is saying do a translation of 1, 2, and then a reflection of this, like we're just going to go in that order. But if I were to write it in correct notation, I would actually have to say reflect the y-axis composed with this translation. And then I would do it in that order. So I'm going to write the points next to these. So this is at -3, 1. And then B is at -3, -4. And then C is at -1, -4. And then once I do that, I'm just going to write my priming points over here, and then I'm just going to plot the final one. So if we start with prime, I first need to do my translation of 1, 2. So I'm going to add 1 and add 2. So -1, 3. B prime, I'm going to add 1 and then add 2. And then for C prime, I'm going to add 1 and then add 2. Then I need to do the reflection of their y-axis, and when I reflect over y, I change x. So looking at my priming points, I'm just going to change the x sign. Oop, I can't on 0. And then I'm going to go plot these final points. So 1, 3 is my A double prime. 2, -2 is my B double. Oh, that feels wrong. Did I count something wrong? Oh my word. Oh yeah, what the heck? When I add it to 1, that should be -2. What a goofball. So A double prime should be here. I knew that was wrong because like it was making a weird line, like it should have been still straight up and down. Okay, and then C double prime is at 0, -2. Does that feel right? Oh yeah, because like it reflected, so it should be pointing in a different direction now. Okay, I like that. And guys, honestly, I'm having that conversation to reaffirm myself. And that's a good conversation to have with yourself as well. Like, okay, it got moved over and it should be flipped around because of the reflection. So, looks good. Alrighty, on to the next. Using the shape here, again, I'm going to write out my ordered pairs next to these points. So A is at 3, 0, B is at 3, -5, and C is at 5, -5. And again, they're telling me the order they want me to do it in, translate, then rotate. But if I was looking at it in correct notation, I would be looking at rotate around the origin 90 degrees, composed with a translation. So it would look backwards. Okay, so to do my translation, first I'm going to add -3 and then add 4, and then go to B and add -3 and then add 4, and then go to C and I'm going to add -3 and add 4. Hopefully I did a better job adding this time. Then I'm going to do a rotation of 90, and when I rotate 90, the rule for that is I'm going to swap and change the first one. So I swap and change the first one, swap and change the first one, swap and change the first one. Okay, so if I go plot these now, A double prime is going to be at, oh, let's think about this. So this guy here is going to get shifted and then rotated 90. So like it's pointing up to me now. And if I rotate counterclockwise 90, it should be pointing like that way now. So hopefully it does that. We'll see. Negative 4 comma 0 is a double prime. 1 comma 0. Oh, 1 comma 0. I was like, negative 1 doesn't look right. That's because it's not a negative 1. And I knew that I didn't want it that close because it should be 1, 2, 3, 4, 5 away. 1, 2, 3, 4, 5 away. And it still is, so that's good. And then C double prime is at 1 comma 2. And so that feels good because it's 2 away from B like it should be. And should be straight up because we should maintain that it's a right triangle. Oh my goodness, so cute. Sorry, this video is getting real long. If you feel good about it, you can skip these last two, but I'm going to keep going. So here we go. We're going to translate, then reflect. But if I was writing this out in correct notation, I would reflect, compose with a translation. Oop. Those are like vector things if you take physics. But anyways, A is at negative 3 comma 3. B is at negative 3 comma negative 2. And C is at negative 1 comma negative 2. And so if I do that translation first, we're going to add 4 and then do nothing. So if I start with A, add 4, do nothing. B, I'm going to add 4, do nothing. And then I'm going to add 4 and do nothing. And then when I reflect over the line y equals x, we just swap. Okay, so I'm going to take each of these points and just swap them. So 3 comma 1, negative 2 comma 1, negative 2 comma 3. And then I'm going to go plot. So 3 comma 1, negative 2 comma 1. Okay, I feel good so far. Like I'm maintaining this flat line as I should. It did get flipped, it feels like, but a reflection over y equals x is kind of like a flip because we swap where the points are. And it's a reflection, so yeah. And then C is at negative 2 comma 3, so that also feels good because it maintained that distance of 2 between them. So if we think it through step by step, guys, if I translate this 4, I'm going this way 4. And then if I reflect it over this line here, it's going to get flipped that way. So it does make sense and looks all good. And then lastly, we're going to translate, then rotate. And so if we talk about that in correct notation, it would look like rotate, then translate, composed with. Alrighty, so this point here is at negative 1, 1, B is at negative 1, negative 4, and C is at 1, negative 4. And so if I do my translation first, I'm going to subtract or add negative 1 and then add 3. So if I add negative 1, it's negative 2, then 4. And down here on B, if I add negative 1, it's negative 2, and then add 3 to negative 4, it's negative 1. And then C, add negative 1, and then add 3. Then when I do a rotation of 180 degrees, I simply change both the signs. So A double prime will be at positive then negative. B double prime will be both positive. And C double prime will be positive. Okay, so if we go plot these now, we're going to go 2 comma negative 4. That feels funky, but let's just keep going. I usually need 2 points to feel good about it. B double prime is at 2 comma 1. Okay, I feel good about it now because we maintain that straight line. Also, like if we do think about it, a rotation would flip it. So like A would come to the bottom and B would go to the top. So I feel good about that. And then finally, C is at 0 comma 1. And that feels good as well because it's still 2 away from B. Awesome. Oh my God, that's so cute. It almost looks like a double rotation. That's adorable. Anyways, there we go. We're going to start reviewing and then take a little quizzy quiz.